Hey guys, this is how to set up a Omron servo in Sysmac Studio. First things first, we'll start a new project. Demo. I'm using a 1P2 for this one. I'm on 1.6. You can change this out later if you need. For now, hit create. Alright, so we have an EtherCAT servo, and we are using one of the 1S drivers. So, first things first, open your EtherCAT here. You'll see the master, which is the PLC, and you can search for your servo controller over here. So in my case, I am using a R80D dash, gotta include the dash or I won't find it, 1SNO4H, this one. So once you've identified the driver you're using, drag it over on top of your master, and it'll create the link to it. You can chain these later, but for purposes of this demo, we're only going to use one. You can assign the address here of whatever node you're using. We only have one drive, so it's node 1. Obviously enable it. And it created the node down here, which will have all of the settings we need to configure it. So start clicking on parameters. And this is a pretty large list of configurable things in your driver. I'm not going to go through all of this. Important to know it exists. And it has a lot of your pretty standard functions or settings, a lot of variables you can set here as to how the motor will behave. The one I do want to go over is there is configurable I/O on these. So we can see we scroll down to 4600s over here, and we can see that's prohibition input. They just default assigned it to input 2. If we click on this drop down, we can assign it wherever we want. A couple of ones you might be interested in are the home proximity input. So if we're doing a home switch, you can just use one of the inputs on the controller for the home switch. By default, it's input 4. And then same thing, it has outputs as well. Yeah, if we scroll down, we get our outputs. You can allocate it wherever you want, and then you can make it normally open, normally close contact. But it's important to know that this exists. And these are for doing like data trace, like when you're running the servo. We're not going to cover that right now. The important thing is know that we created the node, and these are the parameters for some of the settings. To create the axis that you can use in your program, and just for real quick demo, all of the motion control MC, so all of your motion control commands are in this drop down, and just like a real common one will do like a relative move. You don't need to do this. I just want to kind of show you what it's expecting. Is for every function block of a relative move, it's expecting an axis, which will be the axis that we create in a minute here. So we'll get rid of this. So to create that axis, we have this motion control setup. You can right click on this. Right click on axis settings, add, case single axis position control axis. And this is, okay, so it creates this called axis 0, axis use, I don't know what these mean, used axis. Okay, axis type, it's not virtual, it's going to be a servo axis because that's what we have. And the output device is that controller. So this is the same thing as right here. This is what we created, so we know that this axis corresponds to that controller. And then you can rename this whatever you want. So in my case, I have a rotary axis on the machine I'm working on right now. So we'll just do rot axis. And so now when we go to our program again, let's just throw this in real quick. Home. Now we can refer to it by rot axis. And now it knows that whatever function this is acting upon rot axis, which is this motor on this controller. All right, let's go through a few more settings real quick. So this rote axis. So if you double click on your axis, you end up closing this, just double click here, it'll open the menu. So this is kind of your real basic, it's assigned to this controller and just a couple of general settings about it. Next is your units. So I should really just leave this up. All right, we're going to do a relative move. Okay, so it's expecting your axis, right? And then it has these distance, velocity, acceleration, but there's no units. So I can do a distance of like 10. 10 what, you know? So based on whatever you click here, it's that unit. So 10 pulses is probably barely even moves. 10 millimeters, a little bit more. And then I have a rotary, so I'm going to do degrees. So now when I do do a move relative and I input 10, it's 10 degrees. Okay, so next we have in the configuration of how the motor is going to move, we have pulses per revolution. So in my case, you have to look this up for your specific motor. You can actually just Google it and it'll probably pull it up. So in my case, I have an R88M 1M400 30 TBS2 motor. And if you just Google how many pulses per revolution for 8388608. So we put that number in 8388608. That's what it was. Okay, that's what it was. You saw this went red. We'll address that in a second. But that's basically because now we raised this number so high, it's kind of getting unreasonable acceleration and velocity values. But one thing at a time. So our motor is that many pulses per revolution. So now, work traveled per motor rotation. So there's a couple ways that you can do this. You can click use gearbox, and then it will kind of do the math for you. You can kind of go through the menus here and figure out, your work gear ratio, motor gear ratio, all this stuff. It's fine. It's a little convoluted. I kind of know that I'm using 121-to-1 gearbox on the motor I have. So I can just do 360 divided by 121, 2.9752. So through my gearbox, for every revolution of the motor, my table will spin 2.9752 degrees. So that's what I put in here. So now we know when we go here and I tell it to move 10 degrees, it'll actually move the motor enough times, it'll apply this factor so that I actually get 10 degrees output. Or if you have a linear axis, you can do this. Also, if you have a linear axis, you probably want to use anything but degrees. All right, next section, we have this operation settings. So it's at our maximum value to, 4 billion or whatever degrees per second. Obviously too high. I have a relatively slow operation here, so I'll do maybe 100 degrees a second. That would be plenty for what I'm doing. Start velocity, I'm not exactly sure what start velocity is. I usually just set this to maximum velocity. Jog velocity, we could go maybe a little lower just to be safe. So for jogging manually, there's a screen you can jog the axis manually. We don't want to over speed for that. Acceleration, you can usually go a little higher on this. 1,000. Obviously do the math and the calculations to figure this out correctly. I'm just throwing numbers in for get something moving. Yeah, a couple other options here. Like if you tell it to reverse, do you want it to decelerate or just stop? Things like that. Just kind of go through the menus. They're pretty self-explanatory a lot of the time. This is kind of interesting. So if you start getting to a maximum velocity, we can set up a warning bit. Same with acceleration and deceleration. You can usually set these pretty high, but again, based on your application. And then this in position range is pretty important too. So it defaults to 10 degrees. So basically, if I tell it to move to 200 degrees and it's at 190, because I'm within 10 of 200, it'll say it's in position. That's obviously way too much of a tolerance for what I'm looking for. 0.1 works plenty for me here. So now if I tell it to go to 200 degrees, it has to reach at least 199.9. The rest of this, zero position range, you can kind of do the same thing, set it to 0.1. The rest I usually use just default values. Okay, next menu, other operation settings. So if you give it like the stop bit, just the behavior here, same thing. If you hit a limit input, how do you want it to behave? Kind of just base this again on your application. Most of this, oh, here you go. So if you want to like do, procs trigger on high or low value, set that here. Do not invert, usually what I do. I think we can leave these mostly the same. We have a software limit. So if you want to just limit how much the motor can move, you don't have a hard stop, but you want to tell it don't go too far, you can enable this with some behavior and then specify your limits. Following error, I believe that's like if you command it a certain position, it expects it to be a certain position at a certain time. So what is allowable? I'm just going to use these default for my application, but based on yours. So homing is pretty interesting. This probably deserves its own video. I don't think I'm going to go crazy through this right now, but basically there's all these different homing inputs, and when you choose one, it kind of gives you the timing map of what it expects and how it will act. And then the other kind of important thing to know right now is your input signal. I usually do use external home input, which if you remember, if we go to parameters, and we go look at our home proximity input, input 4, this will be used as the home switch if you decide to use external home input. Then we got, direction and a couple other things. Homing velocity, just to make this not error, put this something pretty low. But I think maybe another video I'll go a little deeper in this. Just know it exists, play around with it. Okay, next we have the position count. So linear mode, I believe that just like kind of keeps on counting. So, you keep on moving your axis or whatever, it'll just keep on going up. And usually for a linear axis, this is okay because it just physically can't go too far. If you have a rotary and it can go infinite, it might be a little more important to set limits just so you don't get any weird issues when it, gets so high that it turns back to the negative value. So, in my case, I found if I go between 720 and negative 720, that works pretty well. All right, then we have some final settings here. I don't know that I've ever really messed with these. Usually just leave them default. So that is kind of how you do your configuration. So if you want to start playing with it, you can go and just put in some data, do your motion control settings. Otherwise, I'm going to do another video on just like a simple setting. There's a couple of quick settings that are important if you're going to start this the first time, which is if you go to, if you're in this parameters menu, scroll down to 4630.01. This is positive drive prohibition input. So basically, if there's an input, it stops it from moving in the positive direction. By default, this, I don't remember which one it was, but it was one of these, and it's default set to normally closed, meaning if you don't give it power, it will prohibit your input. So if you're just doing some testing, assign this no allocation so it will not prohibit the input. And then do the same for the negative prohibition input. Just assign this no allocation, or I suppose you could just change this to normally open. But make sure you assign those, or else you'll get, I think it's like a 1301 error. You'll get some error about it. You don't want that. And then the last is, it's about 4320. If you're doing a 240 single phase, you want to disable the phase loss detection because it's looking for 3-phase and thinks it won't have it. So just disable this, set this to disabled, and then you can run 240 single phase. Actually, I think this is what gives you the 1301 error. And then when you have the settings ready, you can go online. And you just do transfer all to drive. And then once you do that, it will say they will be enabled after power cycling. So hit OK, power cycle, you're good.